Let's go pop out my chats. And hopefully this time I have audio and everyone can see my whole screen. Because last time I live coded for a really long time and nobody could actually see what I was doing, which was really disappointing. I'm actually disappointed that nobody told me. Really disappointed. I'm actually disappointed. Okie doke. Great. Now let's see. Close that. Get out of that. And we say create React app. Let's zoom in a bit. Whoa. Ah! What did I do? Terminal. Zoom. Pause you. Pop out. Chat, where are you? Okay. We'll see if anyone shows up. No Kiwi today, so maybe people will stay away. And now let's see. CD, documents, random coding, and we say create React app, React D3 flamegraph. Such a weird drink. Oh, I should open my Monster. Okay, now let's figure out what the fuck is a flamegraph. So that's unfortunate. So I have here Andy Kirk's amazing data visualization book with a lot of poops from my bird, unfortunately. Okay, let's see. CD React D3 flamegraph yarn start. Now let's see. I know there's a section here that has all sorts of different charts because I have totally forgotten what a flame graph is. See? Charts. So let's figure this one out. Bar chart, clustered bar chart, dot plot. Should have a camera. Oh, actually I can do that. Let's see. Let's see if I can help you guys see what I'm doing. There we go. Okay. So clustered bar chart, dot plot. I'm sure there's going to be a flame graph in here. Connected dot plot, pictogram, bubble chart, proportional shape chart, polar chart, radar chart. Oh, this works pretty well. I should use this trick more often. Box and whiskers, range chart, univariate scatter plot, univariate scatter plot, histogram. Also wrongly known as bar chart apparently. Pie chart, word cloud. Stacked bar chart, well, waffle chart. Tree map, back-to-back bar chart. Dendrogram, these are really cool. Venn diagram, those are amazing. Scatter plot chart. Sunburst diagram. Bubble plot. Parallel coordinates, parallel sets. Matrix, heat map. Heat maps are cool. Chord diagram, node link diagram, line chart, Sankey, slope graph, bump chart, area chart, connected scatter plot, stream graph, horizon chart, those are cool. Connected timeline, count chart, instance chart, choropleth map, Proportional symbol map. That's cool. Isarithmic map. What? Dot map. Prism map. That's cool. Flow map. Area cartogram. Grid map. Door link cartogram. What? And that's it. No flame graph. Okay, what the fuck is a flame graph? Also, everything is very blue in my office today. Let's make it a little brighter. Perfect. Okay, guess we have to go bug Brian Bevon on, or no, flame graph. What is a flame graph? Ah, a stack trace visualizer. Gotcha. So this is what we're building. Cool. And we're gonna fake it because we don't have a stack trace handy. We're gonna do it with fake data, unless we can find a data set of stack traces somewhere. But let's build it first. Okay, so that's running. Let's yarn add d3, and we open the project in VS Code, random coding, React d3 flame graph. Cool. Ew, that's dirty. How did that get there? Sorry, I have to be able to see if we want to do this. What am I gonna do? Okay, so we added that, so we can say git init, git commit -a-m, initial CRA setup. So the name of the book was this one. This book. There we go. A handbook for data-driven design. Really useful. I use it a lot when I'm brainstorming how to do stuff. Oh, right, git add dot. Okay. Now let's see. We need to, so to be able to do this, I don't know how we choose world, how we choose the color, but we have basically we need to be able to make a bar and then smaller bars on top, which are actually recursively flame graphs. Cool. So let's see, how do we app.js. So it's this one, so in app.js here we're gonna set this, we're gonna keep the header, and here we're going to what does app intro give us? App CSS. Oh, just font size. Oh, we can keep that. So we're gonna say svg. Why did this not work? And to make our lives easier, the svg is going to have what width is, let's go with 128. Our height is 720, and inside we're going to render a flame graph. And this flame graph is going to get a bunch of data, which is going to come from this .data. So we import flame graph from /flamegraph, and we set data as, what's data gonna have to be as? Let's see, flame graph dataset. Maybe we can just use a dataset. JSON for flame graph. So the hard part always is having a data set. Let's see if this D3 flame graph thingy has one. So we have demo. Wonderful. Ours is not going to be this fancy because I don't have that much time. Or rather, I don't feel like dealing with animation right now. But let's see if the source can give us a data set. So he creates a flame graph. Where does this person feed data into the flame graph? Title, p3 tip, 2 tooltips, stacks.json. Perfect. Where is stacks.json? Stacks.json. Wonderful. So we're gonna steal this format because why not? And we already have a dataset now. Okay. And because we are lazy bastards, we're gonna make our dataset like this. We're just gonna import it directly. Import data from /stacks.json, because we can do that. Dataset from sample dataset from here. Now we have to save this thing. Random coding. Where is it? React. It's gonna be here. React D3 flamegraph. Source. Stacks.json. Okay. Now let's see if this still loads. Yarn start. Now it's gonna say that flamegraph does not exist, isn't it? Or, oh, it's still loading. Come on. No, come on. Is my computer gonna be slow again? Okay. So we need to touch source flamegraph.js. We go into flamegraph and we say import React from React. And we're gonna import D3 later. And we say are we gonna need any? Let's just do it as a class. Extends React component. Has a render method that returns a grouping element for now. Or let's say return group transform with translate $x and $y. So this is gonna let us position our graph. Const x and y come from props, and we export default flame graph like that, and we fix the automatic formatting in VS Code because that is still a problem. Cool. And we say I always forget what's the best way to set default props. Let's just do it here. Like that. Cool. So we have that. Now let's take our data and say console log data. Let's see what it looks like. So we have one root with many children and a value. Perfect. So each thing actually, yeah, we can recursively render flame graphs. So this is the cool thing. We can recursively render them where each one just renders the current. What? Render. Yes, render. Where each one just renders the current level and then recursively asks for more things to be rendered. And to do that, we're gonna use a linear scale, and I think nothing else really, because we just have to, we take the values and we have to pack the values into our known width. So we're gonna need the width as well. Okay, so do we need a linear scale, or is there a scale that can help us out and make this even easier? Let's see. D3. Oh no, I wanted the wiki. D3, come on. Wiki. And we go into API reference. And the API reference, we look at scales just to see if there's a scale that can be continuous, sequential. Do we need a quantas? Let's see. Linear is probably best. Sequential scales. No, we don't need that. We don't need quantization. It's not ordinal. Okay, So it's a yes, we're gonna use a linear scale. So we say import scale linear from D3, and we're going to define that scale here. We're gonna say yes. Let's do it this way first. Import star SD3 from D3, and we're gonna make it better afterwards. So we say x scale equals D3 dot scale linear with so our domain, we arrange to a domain, so our range goes from 0 to D3 max of this.props.data, or let's do it this way, component not will unmount will what, not did update, but derive, yes, so static derive state from props. How does that work again? React derive state there. Oh, come on. React 16.3 life cycles. I always forget the names of these things. Pointer events, what the hell is that? That's new. Derive. Get derived state from props. Get snapshot. Okay. Let's see. Okay. So we get our props and our state is going to start as empty, or let's see. So we say if props.data dot length is different than state.data.length, then we do stuff. So this is a bad way to detect changes in data, isn't it? But let's do it for now. It's a good approximation. Or no. If d3.max of, let's see, what is the shape of our data again? We'll deal with that later. Let's do it this way. Return state with x scale being d3.scale linear, where the range goes from 0 to d3 max of our data. Right? Where did I put that? No. So we get name value, and then this one is going to have name value as an array. So it's an array at each step. Yes. So data with the accessor of d.value. That's our range. And our domain is from 0 to props.width. Yes. So we're gonna say const data comes from props, and so does the width. Yeah. And then we say if width is different than props.width. No. Okay, we're gonna deal with that later. But now we have an X scale in our state we can always use. So we go here and we render this, and we put a let's see, flame rect, which is going to have an X is going to start at 0 for now with with a Y of 0, and it's going to have a width of X scale of d.value. That's going to be our width. So what we have to do here is go through our data and map, and each one is going to return a we iterate and we create a flame rectangle for every element in the array, like that. So we need to know what the sum is at each stage, and that's going to give us the X position. So X is going to be yes. We don't actually have to yeah. Yeah, let's just define the X scale there, because it's not actually benefiting much from all of this for now. So we say const X scale equals all of that. And we can take that out. And our X needs to be data.slice 0 to index. So we get the index from our map, and we reduce all of that as sum d and we say like that, sum plus d dot value, and we start from 0, and then we put all of that into X scale like that, and we have to actually, instead of defining it as a max, we have to define it this way: data.reduce sum d as sum plus d dot value starting at 0. So our maximum number is the sum of all values in our array, with then the x position comes with yes. So the width is the horizontal scale of the value, and the x is the sum of all the values before it. So the maximum one is the sum of all of them. That gives us that. And then we have to say flamegraph, where the data is data.children. And in theory, that should work. We say x is 0 and y should be, oh, we also need to define a height. Let's say height is 10 pixels for now, or rather, let's do it this way. Yeah, so y minus, or actually just height. Let's see, height, or yeah. How do we define the height? Let's say 10, and here the height has to be 10. So now we need to define the flame rectangle, and we say const flame rect equals a functional component that gets x, y, width, and height, and returns for now just a rectangle with x is x, y equals y, width equals width, and height equals height. And then afterwards we're gonna add a label and all of that stuff. So now let's see if this works. We need to get width here as well. Width, and did we put it in? We have to pass it in as 120, 1280. Let's see what happens. Okay, my computer's being slow again. Hi, bird. Let's see if anyone is actually... Yeah, Kiwi, do we want to know if anyone's watching? Or do we not really care? Am I actually streaming? Oh, cool. Some people are watching. That's cool. Okay. Where is it? Data reduce is not a function. How is data reduce not a function? Console log data. Oh. So the data starts as an object. That's unfortunate. Okay, we can fix that. Or rather, let's just fix it in the dataset. Stacks.json, and we add this. And dude, do leaf nodes have Or do they come as an array? Yeah, they do. Okay, so that should work.
Hi.
Cannot read property reduce of undefined. How is data now undefined? Let's see. Okay, let's try this again. We have a console log here. We pass in data which comes from stacks.json. It's very defined. Oh, here I know what we're doing wrong. Here we have to say data.children, and only if we have children do we go and recurse into a new flame graph. Okay, starting development server. Cool. Okay, that kind of worked. Now it complains about iterators. Oh, right. I see what's wrong. Data.children is never defined because we have to do it here. If a data element has children, then we go and do a recursion. And everyone also needs to have a key. Yes. So we can say that this is a React fragment. Like that. So we render a grouping element for our row, iterate through a bunch of elements, render a fragment for each of them, then a flame rectangle, and if children exist, then we pass in children into another level of the recursion. Okay, so it's going through everything. It's not rendering much. Let's see why. Flame graph. That's the rectangle. Perfect. And there's another flame graph which has a bunch of nulls. Why do all these things have problems? Received nan for the. Okay, so let's check this one out. Dude, stop. At flamegraph.js row 5. Yes. Why does it not preserve those? So recursive things are really hard to debug. Let's do this. Let's add a level. So level starts at 0. If we have children and level is smaller than 1, then we go into the next level. And this is going to help us reduce the amount of output so that we can actually potentially debug this thing. Perfect. So what was passed into our flame graph on the second level of iteration? Okay. So let's see. Console log xScale.range and xScale.domain. Let's see what we have. What is being calculated incorrectly? Aha. Width. Because we forgot to pass in the width. So the width can only be as much as this. No. Oh yeah, this is the width. X scale of value. No. Okay, gotta change the battery. So the width of our thing is actually not the entire value. It should be only our width should be only as much as the difference between where our rectangle starts and where it stops. And I'm starting to have a feeling this should be a... Yeah, let's do this. So this is going to be a flame row. Nah. Let's do it this way. Here, in each level of the iteration... wrong battery. Perfect. So each row of the iteration has a start point. Const start is this. And we take the x scale of start. And then end is just data dot value. Or actually, end is start plus d dot value. What is going on now? What is wrong? Oh, that is wrong. So that, like that. Okay, we already have that. And we're gonna return this guy. What is still wrong? Oh. The width here is... let's just call it, let's say x scale of end minus start. And here it's also... yeah. Now that should be fine. Let's see. So d dot value, x scale of start, and this one should also be x scale of start. Let's see what happens now. Cool. We now rendered 2 rows. So we have this flame rectangle, and then we have a... Why does it have this much width? That makes no sense. Okay, let's see. So we have that, and then this flame graph didn't really get a new width, did it? Or it got way too much, which is wrong. Oh, because we map a domain to a range, not a range to a domain. God damn it. Always messes me up. So our domain should be this, and our range should be width, like that. Now let's see what happens. Okay, better. So we have our app, our flame graph, flame rectangle with a full width of 1280, which is perfect. And then this guy has a width of, again, of 1280, because that's the whole thing. Whereas, how do flame graphs look in reality? I feel like I need to... Or maybe that's actually correct, and they do... It's just how that level works. Let's see the demo. No. Actually, yeah. Okay, let's see what happens now if we let go of the entire thing. Or rather, if we let all the levels render, it might look better. It does look better. Awesome. Okay, so that's basically a flame graph. Now we have to figure out how to make the rectangle a little nicer looking and give it some colors. So let's see. Style. Yeah. Stroke is white. Let's see, what does that do? We can remove our console logs because we don't need them anymore. Perfect. So now it looks a lot more like a flame graph. And let's change our height here to say const row height is, let's make it come from above here. Or should we make it come from above? No, that doesn't make sense. Const row height equals, let's say, 20 pixels. So here we say row height, and here we also say row height. And we're gonna get a slightly bigger flame graph. Wonderful. And we can then go in here. I'm not sure how to define colors just yet. Let's see, does this give me any suggestions? Yeah, I have no idea how to define the color for this. Ah, the colors are usually not significant, picked randomly to differentiate flames. No. Okay. Cool. So this is basically, the colors are essentially random. So let's look and see if we have any nice warm colors in the D3 scheme. Or what's the other one, Kiwi, that we like to use? Chroma? Yes. Let's go in here, D3. Wiki. And let's see, API reference. Color schemes. Let's see, is there a good warm color scheme? No, Chroma.js has so much better colors. Color scales. Where are the ones that use brewer classes? Yes, that's the one. Okay, color brewer, Chroma brewer, or RD. Does this one have brewer scales? Aha. Let's see. Brewer. D3 brewer colors. Perfect. So we want to take, let's say, this one. How are they done? Ah, they use color brewer. Yes, I know this is the OR RD one. I'm just trying to figure out how to use it best. Oh well. Yarn add Chroma.js, but I know that the API has something. Like D3 I think has this built in. I just can't remember where it is. RD. There we go. Scheme or RD. So it does exist. Okay, let's do that. So our color here is going to be yarn remove chroma.js, and we say our fill color is d3.scheme or rd. Of 1. Is that how it works? Where are you? No. Let's see if that's how it works. It does not. Yes, everything should have a unique key blah. Let's go to d3.js because I know that they have d3 imported and exposed globally. So what I can do here is I can say d3 scheme or rd and see what it is. Or rd9. Perfect. So or rd9, and we pick math.random times 10 times 9 and math.floor like that. So now we should get random colors from the orange, from the warm or RD scale. There we go. Wonderful. Okay. Now let's actually put some keys in here, and because I'm lazy, I'm gonna say the key is d.name. d.name is a good, actually no, because I'm not sure they are unique. So we're gonna say level key.name. Level minus d.name, and that should be unique, I think. Now it's gonna, now React is gonna stop crying at us. Cool. So our random is not random enough, is it? I think if we do 10, we're gonna get some that never actually show up. Yeah. Cannot read property 0 of undefined. Blah. Okay. Oh. There. Oh, I know what I can do. We can say interpolate, and that's gonna give us a function d3 dot scheme or rd, or rather d3 dot interpolate or rd. Then we can say 0.5, and it gives us a number. Yes. So d3 interpolate or rd, and we can pass in math.random, and this should give us neat stuff. Come on, work. So we need to, okay, what if we say 1 divided by math.floor of math random times 100. So now we're gonna get 100 distinct colors. Let's say we want 50 distinct colors. Yeah, that's not working. Oh. What about like that? what? Screw the colors. Going back to this one. Okay. Now we need to put in the names. We say name equals d.name. This has to be of 9. Like that. So here we say this is a grouping element that is transformed so that it is translated to $x and $y, like that. We no longer, so then our rectangle shows up at 0, and we're going to close the group element. There. And then we render a text element that says our name, and let's see if that shows up. Wonderful, that does show up. Now we have to, I'm gonna remove this class name intro because we do not want the fonts to be that big. Now how do I position text? I think X needs to be 0, Y can be 10, and then style font size is going to be 10 pixels. Let's see if that works. Much better. Okay, font size 10 pixels. Let's move it up to 12, and let's say this should be indented by 5. And let's move it down a little bit so that it's better positioned.
Do you want me to wash your pants though?
No.
Matchy matchy?
Matchy matchy?
Yes.
Sure.
What about the pants on the floor?
No, they're fine. Okay, so we have that. Now we have to make sure that this is not showing up if it is unreadable anyway. How do we do that? Oh, I can also, since we have this rendering, let's see, git add source, git commit -n -n. Okay. Basic flame graph, and let's make a screenshot for our Twitter friends. Dun, dun, dun. Okay, let's go here. Mm-hmm. Okay. Oh, what? I already clicked tweet. Okay. Now, how do we make the labels go away? Okay, so I'm going to change the flame graph actually to be a functional component, and we're going to turn flame rectangle to being not a functional component, because I think that's gonna make more sense. Or no, let's do that. Flame rect class flame rect extends react.component, and we say render const, we get all of this shit from props, and we return all of this shit like that. Now I'm going to do something really cool. This is going to be this dot label ref callback, and label ref callback is going to make sure that we hide the label if it is too big. If element, oh, come on computer, stop being slow. Element dot get bounding client rect dot width is bigger than this dot props dot width, then we say this set state hide label to true. So if so const yeah, like that, and we say state hide label equals, so that's false, and here we say hide label and render the thing, and we get hide label from this dot state. Let's see what happens. So now in theory, everything where the label renders as wider than the thing stops working. And I did it wrong. Come on. At least let me type normally. Like that. So now only the ones where only those rectangles where the label actually fits now render their label. So the next thing I have to do is we have to make sure that we're not importing too much of D3, because that was the original point of this exercise. So let's see, what are we using of D3? Scheme or D, scale linear, and that's about it. So we say import scale linear and scheme or D or RD from D3. Do that, and we say scale linear. Okay. Cool. Now, how do we make the labels visible on? I guess the next thing we would want to do is would we want to make the flame graph so that when you click on one of them, it expands and you can... Yeah, we would, wouldn't we? Okay, so how can we do that? How can we make it so you can investigate a specific node? Okay, we're gonna figure that out some other time. Potentially tonight if I have time, but I'm gonna have to do some thinking on whether that's even something we want or useful. Then I'm going to... Basically I have to spend some time thinking about how we can make the nodes so that you can click on one of them and it expands so that it shows the name and lets you explore that part of the graph. For now, this is what we have. It's a basic flame graph built pretty quickly, and in the next stream we're gonna figure out how to make this one dynamic and a bit prettier for Brian Bivon to use. And yeah, thanks everyone for watching. This was short and sweet. We're gonna continue later, and I promise I'm going to figure out how to make my streams of a less high quality so that people can watch them on slower networks. See you guys.